Alright, in this video, I'll be solving the CIE A-Level Math Probability and Statistics 1 Paper 51 for October-November 2024. If you're feeling anxious, overwhelmed, or unsure where to start, then I've created a complete course that streamlines everything with step-by-step videos, interactive quizzes, and an exclusive student community to keep you on track. You can get access to it by clicking the first link in the description. Otherwise, like the video, subscribe, and let's dive right in. Question number 1. Nicola throws an ordinary fair six-sided dice. Dice is plural, but anyways, the random variable x is the number of throws that she takes to obtain a 6. So x is going to follow a geometric distribution because we are looking the number of attempts up until a first success. We're looking at the number of throws up until she gets a 6. Okay, and the probability of getting a 6, since this is a fair six-sided die, would be 1 out of 6. And we want to find the probability that x is less than 8. All right, so I'm going to write this as, because this is discrete, I can write this as x is less than or equal to 7, which allows me to use the formula. The probability that x is less than or equal to r is equal to 1 minus q r. And so here we can come and say this is 1 minus q is essentially just 1 minus p. Okay, so in this case, q is going to be 1 minus 1 over 6, so q is 5 over 6. So that's 1 minus 5 over 6 to the power r. R is 7. So the probability that x is less than or equal to 7 is equal to, that's 1 minus 5 over 6 to the power 7. And this gives us 0.721. And that's our final answer. Part B says, find the probability that Nicola obtains a 6 for the second time on her 8th throw. Okay, so let's write down all throws. She's got a first throw, second throw, third throw, fourth throw, fifth throw, sixth throw, seventh throw, eighth throw. So she gets a 6 on the 8th throw, but her first success is on either of the first 7 throws. We don't know which one. So assuming that it happens on the first throw, we can say that on the first throw she succeeds, so that's 1 out of 6. Multiplied by second throw she fails, 5 out of 6. Third throw she fails, so that's to the power 2, to the power 3, to the power 4, to the power 5, to the power 6, to the power 6. And then on the 8th throw she succeeds. Alright? But because this first success can be either on the first throw, the second throw, the third throw, the fourth throw, the fifth throw, the sixth throw, or even the seventh throw. We're going to have to multiply by 7 for those 7 other outcomes. All right, so now let's evaluate this probability. That's 1 over 6 times 5 over 6 to the 6 times 1 over 6 times 7. This gives us an answer of 0.065. 1. Number 2, the random variable x takes the values -2, -1, 0, 2, 3. It is given that p of x equals x is equal to kx squared plus 2, where k is a positive constant. Part A, draw up the probability distribution table for x, given the probabilities as numerical fractions. All right, so let's start by finding the probability of each outcome in terms of k. So we can start with -2. So the probability that x is -2 is going to be equal to, that's k times -2 squared plus 2. So that's going to be 4 plus 2, which is 6. So you get 6k. And then we go on to the next one, which is our -1. So probability that x is -1 is equal to k times -1 squared plus 2. And this is equal to, that's 1 plus 2, so 3k. Then we go on to the next one, x is 0. The probability that x is 0 is equal to, that's k, 0 squared plus 2, so that's just 2k. And then the next one, which is 2, so probability that x is equal to 2, that's equal to k times 2 squared plus 2, this is 6k. and then we also have 3. So the probability that x is 3, this is equal to k times 3 squared plus 2. This is equal to 9 plus 2, so 11k. So they have specified that they want their probabilities as numerical fractions, so they do not want to see k. How are we going to find what k is? We know that all of these probabilities should add up to 1. So 6k plus 3k plus 2k plus 6k plus 11k, this should all equal to 1. Let's tally up. 6 plus 3, 9 plus 2, 11 plus 6, 17 plus 11, 28. Okay, so we get 28k is equal to 1, so k is 1 over 28. So it means the probability for x is equal to -2 becomes 6 over 28. This becomes 3 over 28. This becomes 2 over 28. This becomes 6 over 28. This becomes 11 over 28. And this becomes, oh, that's all of them. All right, so we can now draw our probability distribution table for x. So that's our x values here, and then the probability that x is equal to x. Okay, so the first value is -2, which has a probability of 6 over 28. The next value is -1, which has a probability of 3 over 28. The next value is 0, which has a probability of 2 over 28. The next value is 2, which has a probability of 6 over 28. And the next value is our 3, which has a probability of, is it 11? Yes, 11 over 28. Over 28. And of course, close the cells of your table and make sure to use a ruler. Do not draw freehand like I am. Okay. So this would be our probability distribution table for x, giving our answers as numerical fractions. Now part B says find the value of var of x. So to get var of x, it's going to be equal to the summation of x squared p minus our expectation of x squared. So we first need to find our expectation of x. Our expectation of x is the summation of x p. So let's find our expectation. That's going to be -2 times 6 over 28, -2 times 6 over 28, plus -1 times 3 over 28, -1 times 3 over 28, plus 0 times 2 over 28. So we're multiplying by 0 there. I'm just going to ignore it. Plus 2 times 6 over 28, 2 times 6 over 28, plus 3 times 11 over 28, 3 times 11 over 28. So the expectation of x is equal to, let's punch this into the calculator, that's -2 times 6 over 28 minus 1 times, that's 3 over 28 plus 2 times, that's 6 over 28 plus 3 times 11 over 28, and this gives us 15 over 14. So our expectation is 15 over 14. So we found this part. We also need to find the summation of x squared p. So the summation of x squared p is essentially going to be this same expression, except now our x is squared. So it's going to be -2 squared times 6 over 28 plus -1 squared times 3 over 28 plus 2 squared times 6 over 28 plus 3 squared times 11 over 28. So the summation of x squared p is equal to, let's punch this into the calculator, that's -2 squared times 6 over 28 minus 1 squared times 3 over 28 plus 2 squared times 6 over 28 plus 3 squared times 11 over 28, and this gives us 75 over 14. So we can say that var of x is equal to our summation of x squared p, 75 over 14, minus our expectation squared, so 15 over 14 squared. Okay, and so the var of x is equal to, let's punch this into the calculator, 75 over 14 minus 15 over 14 squared. This gives us 825 over 196. If we're going to give it to three significant figures, this is 4.21, and that's our final answer. Number 3, the time taken in minutes to walk to school was recorded for 200 pupils at a certain school. These times are summarized in the following table. All right, and we've got a table of time taken against cumulative frequency. Part A, draw a cumulative frequency graph to illustrate the data. Okay, so to be able to draw a cumulative frequency graph, you need two things. You need the upper bounds as well as the respective cumulative frequencies. And in this case, they've already given the information to us in a very straightforward manner. That's why it's only 2 marks. All right, so we need to label our x's. On the y-axis, you're going to have your cumulative frequency. Cumulative frequency. And then on the x-axis, you're going to have your time taken in minutes. Time taken in minutes. And we need to come up with a scale. So looking at the x-axis, we have a total of 70 minutes. Okay, so the maximum time taken is 70 minutes. So let's count how many big boxes do we have, if I can even see the big boxes. Cambridge should really do better here because these are hard to see. Okay, when we zoom in, we can see them more clearly, but now I can't find my pen. All right, so we've got 1, 2, 3, 4, 5, 6, 7. Okay, so that's fine. I can move in tens here on the x-axis. So this will be 0, 10, 20, 30, 40, 50, and then we've got 60 and 70. So 60, 70, perfect. All right, let's zoom out. And then we need to create a scale for the y-axis. So in the cumulative frequency axis, we're going up to 200. Let's see how many boxes we've been given in the y-axis. All right, so we start here, and then we've got 1, 2, 3, 4, 5, and we've got 6. Okay, so what is 200 divided by 5? Yeah, I think the best scale is to move in either 50s or 40s. I think let's move in 40s. So we can say 0, 40, 80, and this is 120, that is 160, and then there we are going to have our 200. All right, and now we can start plotting. Maybe let me use a thinner pen for plotting. Our first point, you always mark the point 0, 0. Okay, so mark the point 0, 0, and then we go on to the point at which our time is 15 and cumulative frequency is 18. So we want time to be 15 and cumulative frequency to be 18. So each small box is going to be 4 units in the y-axis. So if we're saying 15 is right here, and we want 18 units, that's 4, 8, 12, 16. So somewhere here, Let me see if I can get something a little bit more accurate. I think somewhere there would be our 18. And then we've got 25 on time and 46 on cumulative. 25 on time, so that's bang in the middle here, 25. And we want, what do we want? We want 46 on cumulative. So we start here, that's 40, and this is 44. So 46 is going to be somewhere there. And then we go on to 30 and 88. So time is 30 and cumulative frequency is 88. So 80, 84, 88 is right here. Okay, and then next we've got time is 40, cumulative frequency is 140. Time is 40, cumulative frequency is 140. So that's going to be, just count 5 boxes here, 1, 2, 3, 4, 5. This is 140 right there. Okay, and then we've got time is 50 and 176. All right, so 50 is this line here, and we want 176. So we know that bang in the middle, 1, 2, 3, 4, 5 would be 180, but we want 176. So subtract 4 units. That will be your 176. And then finally, we want a time of 70 and a cumulative frequency of 200. So 70 is this line here, and 200 is right over there. Okay. And then now we want to draw our cumulative frequency curve. So it's just joining those points and trying to get a nice S-shaped curve. All right. Something like that. This will be your cumulative frequency graph. And then part B says use your graph to estimate the median and the interquartile range. Okay, so the median Q2 is at the position half n, where n is the sample size. Here our sample is of size 200. So the median is going to be at a position of, or at a cumulative frequency of 100. Half times 200 is equal to 100. So we are going to draw our construction lines at 100. Let me just zoom in. 100 is going to be in the middle. This will be 100 right there. Okay. So we're drawing our lines to the curve all the way up to right here. And then we start going down here. And you should be using a ruler for these construction lines. Okay. So that's going to be 31, 32, 33. So according to my diagram, it's 33, and you should always give your answers according to your diagrams. Do not guess or write what you think it should be. Write it exactly as it is. So Q2 here, our median, but let me write it exactly as median. Median is 33. And we also need to find the interquartile range. Interquartile range is upper quartile minus lower quartile. Okay, so to get the upper quartile, Q3, that is going to be 3/4 of n. So that's Q3 is 3/4 of 200, which is going to be 150. So Q3 is equal to 150. So let's draw construction lines at a cumulative frequency of 150. So where is 150? Let's start at 160 and move backwards. This is 156. This is 152. So 150 should be in the middle of that box. Let me zoom in. Okay. So 150 should be right there. Let's draw construction lines. And they do want to see these construction lines. You do get marks for them, so make sure to show your construction lines. according to my diagram, Q3 is 43. I'm going to come and say that our interquartile range here is going to be that 43, and we need to find Q1. Q1 is going to be a quarter in. So Q1 is equal to a quarter of 200. So we get that Q1 is equal to 50. All right, so we need to draw construction lines at a cumulative frequency of 50. Okay, so zoom in, and we want to find 50. So we know that this is 44, that's 48, so 50 would be right in the middle there. Okay, now let's draw construction lines. And here we're getting 26. So according to my diagram, our lower quartile is going to be 26. Okay, so I conclude that my interquartile range is equal to 43 minus 26, which is 17. And that's my final answer. Part C says calculate an estimate for the mean value of the times taken by the 200 pupils to walk to school. Alright, so to be able to calculate mean, we need a table of the midpoints of each class against their respective frequencies. So midpoints against frequencies. Frequency. Alright. So let's look at the table we've been given. So here they've just given us the upper bound of each class, but we can deduce the lower limit of each class. This first class is technically starting from 0 and going all the way up to 15. And then the next class should be from 15, and this is going up to 25. Then the next class is from 25, and this is going up to 30. Next class will start from 30, and it will go up to 40. Next class will start at 40, and it will go up to 50. And then the final class will start at 50, and it will go up to 70. We've got 1, 2, 3, 4, 5, 6 classes. 1, 2, 3, 4, 5. Yes, it matches. Okay, so we need to find the midpoint of the first class. So the first class is going from 0 to 15. Its midpoint is going to be 0 plus 15 divided by 2, which is 7.5. Okay, so 7.5. And we do the same for the next class. The next class is going from 15 to 25. So 15 plus 25, that's 40. 40 divided by 2, that's 20. Okay. And then the midpoint of the next class, that's 25 plus 30, that gives us 55 divided by 2, which is 27.5. Okay. And then the next class is going from 30 to 40. Its midpoint is going to be 35. And then the next class is going from 40 to 50, so midpoint is 45. And then the final class is going from 50 to 70, so midpoint is 60. All right, so that's 60. Now we found all our midpoints. We need to find our frequencies. Okay, so we've got cumulative frequency. For the first class, the cumulative frequency is the same as the frequency. So that's just going to be 18. And then for the second class, remember cumulative frequency is just the total frequencies up to that class. So it means in this case, this 46 here represents the frequency of the first class plus the frequency of the second class. So if we just want the frequency of the second class, we can say 46 minus 18, because the frequency of the first class is 18. If we remove it from the 46, we remain with the frequency of the second class. So that's 46 minus 18, that's 28. So this is 28. And then, so this cumulative frequency is all the frequencies of the first three classes. So if we subtract the frequencies of the first two classes from this, we should remain with the frequency of the third class. So 88 minus 46. 88 minus 46, that's 42. 42. And this same logic will continue to apply. This is frequencies for first four classes. So subtract frequency of the first three classes. That should leave you with frequency of the fourth class. So 52. And then this is the frequencies for the first five classes minus the frequencies of the first four. 176 minus 140, that gives us 36. So 36. And then finally, there's just going to be 200 minus 176, which is 24. Okay. So we now have a table of our midpoints against their frequencies. Now we can finally calculate our mean. And the formula we are going to use is that x bar is equal to the summation of x f over the summation of f, where x are our midpoints and f is the frequency. So let's start off by finding the summation of x f. Okay. So let me just return to my thickness there. That's the summation of xf is equal to, it's going to be x times f, so 7.5 times 18, plus 20 times 28, plus 27.5 multiplied by 42, plus 35 times 52, plus 45 times 36, plus 60 times 24. All right, so the summation of xf should be equal to, let's punch this into the calculator, that's 7.5 times 18 plus 20 times 28 plus 27.5 times 42 plus 35 times 52 plus 45 times 36 plus 60 times 24, and this gives us 6,730. All right, so this becomes x bar is equal to, our summation of xf is 6,730 divided by our total frequency. Remember, we're dealing with 200 pupils, so our total frequency is 200. So this means x bar is equal to 6,730 divided by 200. That gives us 33.65. And this here is our final answer. Number 4. Rahul has two bags X and Y. Bag X contains 4 red marbles and 2 blue marbles. Bag Y contains 3 red marbles and 4 blue marbles. Rahul also has a coin which is biased so that the probability of obtaining a head when it is thrown is 1/4. Rahul throws the coin. If he obtains a head, he chooses at random a marble from bag X. He notes the color and replaces the marble in bag X. He then chooses at random a second marble from bag X. If he obtains a tail, he chooses at random a marble from bag Y. He notes the color and discards the marble. He then chooses at random a second marble from bag Y. Part A. Find the probability that the two marbles that Rahul chooses are the same color. So, what are the scenarios we can have? We can have that Rahul picks up a head, which means that he's choosing a random marble from big X. So let's say the first pick is going to be a red marble, and then the second marble that he picks will be a red marble again. This is one possible scenario. Or he could flip the coin and get a head, and then get 2 blue marbles. Or alternatively, you could get a tail and pick 2 red marbles, or throw a tail and then get 2 blue marbles. So we need to evaluate the probability of each of these scenarios. So here the probability of throwing a head is going to be a quarter. All right, multiplied by, he chooses at random from bag X, he knows the color. Okay, so how many marbles are in bag X? We've got a total of 6, and we want to get a red marble, so that's 4 out of 6, multiplied by, he replaces the marble in bag X, so it means our total for the second pick is still 6, and we still have 4 red marbles because he has replaced the marble he took. Okay, and so this here would be, that is 1 over 4 times 4 over 6 times 4 over 6, which gives us 1 over 9. And then the second scenario, he rolls a head, which is a quarter, multiplied by, in big X, we've got a total of 6 marbles, and blue marbles, there's 2 of them. So he's got 2 out of 6 chances of getting a blue marble. And then for the second pick, he's replaced the blue marble that he initially took. So there's still a 2 out of 6 chance of getting a blue marble. So that's going to be a quarter times 2 over 6 times 2 over 6, which gives us a 1 over 36. And then let's evaluate the probability of this scenario. Since the probability of obtaining a head is a quarter, it means obtaining a tail is 1 minus a quarter, which is 3/4, multiplied by, we've got a total of 7 marbles in bag Y, so 7, and we're saying he chooses at random from bag Y, he knows the color. Okay, so to get a red marble, how many red marbles are in bag Y? There's 3 of them, so 3 out of 7, multiplied by, he knows the color and discards the marble, so he doesn't replace, meaning that we're left with 6 marbles, only 2 of which are red because he's already discarded a red marble. And this is equal to, this is 3 over 4 times 3 over 7 times 2 over 6, and this gives us 3 over 28. And then the final scenario we could have is that he gets a tail, which is 3/4, multiplied by getting a blue marble in bag Y, that's 4 out of 7. And he doesn't replace this blue marble, so it means we're now picking from 6, only 3 of which are blue. So this is 3 over 4 times 4 over 7 times 3 over 6, which gives us 3 over 14. So let's tally up the probabilities. Total is equal to 1 over 9 plus 1 over 36 plus 3 over 28 plus 3 over 14, and therefore the total is equal to, this is 1 over 9 plus 1 over 36 plus 3 over 28 plus 3 over 14, and this gives us 29 over 63, and that is our final answer. Part B says find the probability that the 2 marbles that Raoul chooses are both from bag Y, given that both marbles are blue. So this is conditional probability. So the formula for conditional probability is the probability of B given A is equal to the probability of A intersection B over the probability of A. All right, so let's define our events. What is A? A is the given event, so that's both marbles are blue. Both marbles are blue. Both marbles blue. And then what is B? Find the probability that the 2 marbles that Raoul chooses are both from bag Y. All right, so B is both marbles from bag Y. Both marbles from bag Y. And so the intersection of A and B is both marbles blue, both marbles blue, and from bag Y, and both from bag Y, both from bag Y. So let's start by finding the probability of A, the probability that both marbles are blue. The probability that both marbles are blue is going to be this probability added to this probability. It's the probability of getting a head and then 2 blue marbles, or getting a tail and then 2 blue marbles. So the probability of A is going to be equal to, that's 1 over 36 plus 3 over 14. So 1 over 36 plus 3 over 14. So the probability of A is equal to, let's punch this into the calculator, that's 1 over 36 plus 3 over 14. So that gives us 61 over 252. And now we want to find the probability of our intersection. So the probability of A intersection B, this is both marbles blue and both from bag Y. So when do we pick bag Y? We pick bag Y if we get a tail. So it means that the intersection is just the probability of getting a tail and picking both blue marbles. Probability of getting a tail and getting both blue marbles. So that's going to be just 3 over 14. So we can say that the probability of B given A is equal to our 3 over 14 divided by our 61 over 252. And so the probability of B given A is equal to, let's punch this into the calculator, that's 3 over 14 divided by 61 over 252. This gives us 54 over 61, and that is our final answer. Number 5. The weights of the green apples sold by a shop are normally distributed with mean 90 grams and standard deviation 8 grams. Part A. Find the probability that a randomly chosen green apple weighs between 83 grams and 95 grams. Alright, so let's define our random variable x. Let x be the random variable weight in grams of green apples. Green apples sold by a shop. Apples sold by a shop. And we know that x follows a normal distribution with mean 90 grams and standard deviation 8, so that's just 8 squared. Okay, and we want to find the probability that a randomly chosen green apple weighs between 83 and 95 grams. So we want to find the probability that x is greater than 83 but less than 95. Okay, so let's standardize. This is going to be 83 minus our mean, which is 90, divided by our standard deviation, which is 8. This is less than z, which is less than 95, minus our mean, which is 90, divided by our standard deviation, which is 8. And so if we simplify, we've got 83 minus 90 over 8, and this gives us negative 0.875, and this is less than z, which is less than 95 minus 90 over 8, which gives us 0.625. Okay, and we can write this as phi of 0.625 minus 1 minus phi of 0.875, and then just read off the respective values from our normal distribution table. So that's going to be 0.7340 minus 1 minus 0.8092. And so punch this into the calculator. This is 0.7340 minus 1 minus 0.8092, and this gives us that 0.543, correct to 3 significant figures. Part B. The shop also sells red apples. 60% of the red apples sold by the shop weigh more than 80 grams. 160 red apples are chosen at random from the shop. Use a suitable approximation to find the probability that fewer than 105 of the chosen red apples weigh more than 80 grams. So let's define our random variable R. Let this be the random variable. Number of red apples that weigh more than 80 grams. Weigh more than 80 grams. And R follows a binomial distribution with n being 160 and the probability of success being 0.6. All right, and now we are required to use a suitable approximation. We've got a binomial distribution, so we are going to be using a normal approximation to the binomial distribution. And at AS level, this is the only approximation you use, but it's always good to check if the conditions are met. So let's check NP. NP is going to be 160 times 0.6. So NP is equal to, that's 160 times 0.6, 96, which is greater than 5. So it matches the condition that NP should be greater than 5. Now let's check NQ. NQ is 160 times, remember Q is 1 minus P, so Q is equal to 1 minus, that's 0.6, so Q is 0.4. So that's 160 times 0.4. 160 times 0.4, which is 64. So you get that NQ is equal to 64, which is greater than 5. And it matches both conditions, which are NP is greater than 5 and NQ is greater than 5. And so because these conditions are met, we can use a normal approximation to the binomial distribution. Okay? And when we do this, our x follows a normal distribution with the mean being NP and the variance being NPQ. Mean we already calculated to be 96. We need to find NPQ. NPQ is 160 times 0.6 times 0.4. So NPQ is equal to, this is 160 times 0.6 times 0.4. This gives us 38.4. So it means X follows a normal distribution with mean 96 and variance 38.4. And we are required to find the probability that fewer than 105, so less than 105, probability that X is less than 105. Remember that this question was defined under discrete conditions, and we have approximated to a distribution which is continuous. So we have to apply continuity correction. 105 under continuous conditions represents all values from 104.5 all the way up to 105.5. So we don't want to include any value from 105. So it means we want to essentially take values that are less than this value and move to the left so that we don't include 105. That means we're taking the probability that X is less than 104.5. 104.5, all right? And now we can go ahead and standardize. So that's less than 104.5 minus 96. And this is over the square root of 38 minus 38.4. All right, so let's punch this into the calculator. That's 104.5 minus 96 over the square root of 38.4. And this gives us 1.372. And so we need to find phi of 1.372. And this would give us our final answer. And if you read from the normal distribution tables, we should get 0.915 correct to 3 significant figures. Number 6. The heights of the female students at Brevin College are normally distributed. 90% of the female students have heights less than 182.7 centimeters. 40% of the female students have heights less than 162.5 centimeters. Part A. Find the mean and standard deviation of the heights of the female students at Brevin College. Okay, so let's start by finding our random variable h. This is the heights in centimeters of female students at Brevin College. Female students at Brevin College. Okay. And in this case, we don't know what the parameters are, but we know that it's normally distributed, is mu and sigma squared. And we've been told that 90% of the female students have heights less than 182.7 centimeters. So that's the probability that the height is less than, so h is less than 182.7. We are told that this is equal to 0.9. And we've also been told that the probability that the height is less than 162.5 is equal to 40%, so is equal to 0.4. And what we can do here is we can standardize. So this would be z is less than 182.7 minus our mu divided by sigma. And the probability would still be the same, and we'll do the same here. This is z is less than 162.5 minus mu over sigma, and this is equal to 0.4. And I'm just going to rewrite this as z1 so that it's a bit more readable. So z is less than z1. This is equal to 0.9. And we can do the same here, but I'll rewrite this as z2. Z is less than z2 is equal to 0.4. Now let's draw a bell curve for our problem. So here, this would be 0. By saying the area to the left of z1 is 0.9. So that must mean that z1 is to the far right. It would be z1 and the area to the left of it is 0.9. Okay? And then for this situation, for z2, the area to the left of z2 is 0.4. So z2 should be maybe somewhere here. And it's going to be negative. So take note of that because it's to the left of 0. Okay, so this area here is 0.4. Okay, so how would we find z1? z1 would be arc-phi of 0.9, our area here. So just read your tables in reverse and find the z value that corresponds to a probability of 0.9. That's going to be 1.282. And then to find our z2, it's going to be, if you look at your normal distribution tables, the areas start from 0.5, so we can't use 0.4, but instead we can say 1 minus 0.4 to give us 0.6. Both these probabilities are tied to the same z value. So it means that if you say arc-phi of 0.6, you should get the correct z value. And the z value that you get is 0.253. But remember, from our diagram, we can tell that z2 must be negative, so add a negative sign here. Okay, so once we've done that, I want you to take note that z1 is just a placeholder for this expression over here. So in other words, z1 is equal to 182.7 minus mu over sigma. Okay, so we can say that 1.282 is equal to 182.7 minus mu over sigma, which we can multiply through by sigma to make it linear. So 1.282 sigma is equal to 182.7 minus mu. All right. And then we can do the same here for z2, because again, z2 is just a placeholder for this expression. So it means z2 is equal to, that's 162.5 minus mu over sigma. So that means our Z2, which is negative 0.253, is equal to, that's 162.5 minus mu over sigma. We can multiply through by sigma, so that we've got negative 0.253 sigma is equal to 162.5 minus mu. Notice how we now have two equations in terms of mu and sigma. We can solve these two equations simultaneously to find our mean and standard deviation. So I'm going to make mu the subject of the formula in this equation. So it's going to be mu is equal to 162.5 plus 0.253 sigma. Okay. All right, so I'm just going to take our two equations to the side so that we can clearly see what's going on here. We've run out of space. All right. And what I want to do is I want to replace this mu with this expression that we have here. So that is 1.282 sigma is equal to 182.7 minus our mu, which is 162.5 plus 0.253 sigma. Okay, so 1.282 sigma is equal to 182.7 minus 162.5 minus 0.253 sigma. Now let's put this sigma, this term in sigma to the left, so that it's 1.282 sigma plus 0.253 sigma is equal to, that's 182.7 minus 162.5. All right, so on the left, we've got 1.282 plus 0.253. That gives us 1.535 sigma is equal to 182.7 minus 162.5. And this gives us 20.2. I both sides by 1.535. 1.535, and sigma is equal to, so that's 20.2 over 1.535, and this gives us 13. I think for now, let me actually just write it as an exact value because I want to use it to find mu. 40 over 307. So that means would be mu would be 162.5 plus 0.253 multiplied by 4040 over 307. So mu is equal to, that's 162.5 plus 0.253 multiplied by 4040 over 307. And this gives us mu is 165.8, and sigma here, if you round off sigma, you get, that's 4040 over 307, you get 13.2. So these would be our mean and standard deviation. 10 female students are chosen at random from those at Brevin College. Part B, find the probability that fewer than 8 of these 10 students have heights more than 162.5. Alright, so let's define our random variable here. Number of female students at Brevin. Female students at Brevin with height more than 160.5 centimeters. So as soon as you see that a sample is chosen at random, chances are you're now moving to a binomial distribution. So in this case, it's f follows a binomial distribution, and 10 is our sample size, so 10. And the probability of success is going to be the probability that they have a height more than 162.5. Just gonna check if we were given this earlier. Okay, so we know that 40% have a height less than 162.5. So it must mean more than 162.5 is 1 minus the 40%, which gives us 0.6. So it means our probability of success here is going to be 0.6. And we want to find the probability that fewer than 8 of these 10 students have a height more than, okay. So fewer than 8, less than 8, which we can write as 1 minus the probability that f is greater than or equal to 8. So here we're going to evaluate 8, 9, and 10. So this becomes 1 minus, we're going to start with 8, so that's going to be 10, choose 8 times 0.6 to the 8 times 0.4 to the 2 plus 10, choose 9 times 0.6 to the 9 times 0.4 plus 0.6 to the 10. So let's punch that into the calculator. That's 1 minus 10, choose 8 times 0.6 to the power 8 times 0.4 to the power 2 plus, that's 10, choose 9 times 0.6 to the 9 times 0.4 plus 0.6 to the 10. And this gives us, that is 0.833, and that will be our final answer. Number 7, part A. How many different arrangements are there of the 9 letters in the word intellect in which the 2 T's are together? Okay, so we want to put our 2 T's together, and then we've got 7 remaining letters, 1, 2, 3, 4, 5, 6, 7. So that's I, that's N, that's E, that's L, that's L, that's E, that's C. Okay, so how many things are we rearranging? 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial. Do we have any repetitions? Yes, the E appears 2 times, so divide by 2 factorial. The L appears how many times? 2 times. Okay, that's a C multiplied by 2 factorial in the denominator. And so this will be our answer, though we have to simplify it, of course. So 8 factorial over 2 factorial times 2 factorial. This gives us 10,080. Part B. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the 2 E's are not next to each other? So to get what they want, we could just say total arrangements in which the T's are at ends with no other restrictions, minus T's at ends and E's together, and E's together. Because if you subtract these two, what remains are just going to be your T's at ends, but E's are not together, which is exactly what they want. So the total where the T's are at the ends, we're going to have a T here, then 1, 2, 3, 4, 5, 6, 7, and the other T here. So that's I, N, E, L, L, E, C. All right, so we are rearranging because the T's are fixed in position. We are not going to include them in our calculation. So we're rearranging 1, 2, 3, 4, 5, 6, 7. That's 7 factorial. And this is over. The E's appear twice, so divide by 2 factorial. The L's appear twice, so also divide by 2 factorial again. All right. So what does this simplify to? This is 7 factorial over 2 factorial times 2 factorial. That's 1260. Now we want the T's are again fixed in position. So that's 1, 2, 3, 4, 5, 6, 7, and then a T. And so we've got, but in this case, we want our E's together. So I'm going to group our E's right here into the slot. and then we've got I, N, L, L, C. Okay, so we are rearranging again. T's are fixed in position, but the E's have been paired together, but they can be rearranged. So we're rearranging 1, 2, 3, 4, 5, 6 things. So that's 6 factorial. How many repetitions? Only the L's are repeating. So that's over 2 factorial. Okay. 6 factorial over 2 factorial, that gives us 360. And we're getting the difference between those two. So 1260 minus 360, this gives us our final answer of 900. 4 letters are selected at random from the 9 letters in the word intellect. Part C, find the percentage of the possible selections which contain at least one E and exactly one T. All right, so the expression we're going to have here is we want at least one E and exactly one T, and exactly one T, and this is just over the total possible selections without restriction. So total possible selections. And of course, at the end, we're going to multiply by 100 so that we get it as a percentage. Oh, let's write down the possible combinations that we could have for at least one E and exactly one T. So we could have exactly one E and exactly one T, or we could have two E's and just one T. These are the two possible scenarios that satisfy this statement here. Okay, so let's evaluate that. That's E and T, 1, 2, 3, 4. So we're going to preemptively select an E and preemptively select a T. But because we've selected both an E and a T, we want to take them out of the selection pool for the last two slots as well. So it means for the last two slots, we're going to be picking from I, N, L, L, and C. Let me send letter 1, 2, 3, 4, 5. So let's evaluate this scenario. We've got a total of two E's and we want to select one. So that's 2, choose 1. We've got a total of two T's and we want to select one. So that's 2, choose 1. And we are going to remove all those T's and E's because in these final two slots, we do not want to select them. So it means now our selection pool is just these 5 letters. So we're picking from 5 and we want to pick any 2. So that's just 5, choose 2. Okay, so let's punch that into the calculator. That's going to be 2 times 2 times 10. So that's 40. This is 40. And then I'm just going to move this second scenario downwards so that we have more space to work it out in. Okay, so here we've got, again, 4 slots, but here we want to select both E's and one T. So that's going to be, again, we've got a total of 2 E's, so we're picking 2 from 2. And then we want to pick one T from 2. And then finally, we're picking from these 5. And we only have one slot remaining for those 5. So that's going to be 1 times 2 times 5, so 10. And so the total there is going to be 50. And so essentially what you're going to have is that we're saying for this top statement, we've got 50. And then the total possible selections without any restrictions are going to be, we are picking from 9, so it's 9. And we want to choose 4 letters, so 9, choose 4. So this is 50 over 9, choose 4. That's, what is 9, choose 4? That's 126, so 50 over 126. And they say they want this as a percentage, so we can multiply by 100. So 50 over 126 multiplied by 100 gives us 39.7% to 3 significant figures, and that's going to be our final answer. And I believe that's the paper as well. All right, lovely. If you enjoyed this video or if you found it useful, please share this video with other people who you think might benefit from this. And make sure to leave a like, subscribe, and comment down below. What paper would you like to see me break down next? Bye bye.